Dung beetle, family Scarabaeidae, species Scarabaeaceae, and 68, a venerated recycler from the most diverse group of animals on Earth. Beetles come in a greater variety of shapes and forms than any other order of creatures. They comprise more than a quarter of all known animal species. At least 300,000 types have been described to date, but between 3 million and 8 million species are thought to exist in total. These are nature's most varied group of multicellular creatures and have endlessly fascinated men. Why so many species? The answer may lie in a branch of evolution that has only recently come under scrutiny, hidden perhaps because it runs in a contrary direction to the competitive state of nature emphasized by Darwin in his On the Origin of Species. Coevolution is best described as an intimate evolutionary dance between different types of living things in which spiral of mutually beneficial adaptations triggers a diversification into numerous slightly different species. Beetles were the original pollinators of plants and trees, more than 100 million years before the emergence of birds, bees, or moths. Beetles pioneered a mutually beneficial relationship with the first seed-free bearing trees, the cycads, which evolved about 280 million years ago. Until then, the sexual reproduction of plants and trees was a mostly hit and miss affair. Wind power was the only viable alternative transport medium for plants on land. Aquatic plants used water currents, as green algae and mosses still do today, to carry male genes, pollen, to female eggs. But in a world far away from water, wind was all there was. By 280 million years ago, a new mechanism became essential as the world's landmass converged into the one large supercontinent of Pangaea, where rainfall patterns shifted and inland areas became drier than ever. Successful plants and trees were those that produced enormous clouds of pollen. The more pollen, the greater the chance that the wind would blow at least one or two particles towards their intended target. But for any plant, producing so much pollen was expensive and wasteful. All power to those species that found an alternative means of transportation for their precious male genes. Enter the beetle. Even the earliest fossils show how well these creatures adapted to hot, arid environments. Holding wing designs allowed them to squeeze into narrow places, inside cracks, in bark or under rocks, where large fixed-wing predators could not penetrate. This knack of retreating into tight corners served these creatures well in the harsh island environments of Pangaea. Cycads were trees that developed their own innovative response to the challenge of life on a dry supercontinent, producing seeds allow their offspring to germinate without need for constant damp conditions, as required by spores. Seeds contain a store of food packed around the embryo and surrounded by a tough outer coat designed to designed to survive the heat. A second innovation was the ancient cycads production of scents that attracted beetles to feast off their pollen and seeds. As the beetles roamed around neighboring trees, they spread the cycads pollen, a far more efficient and targeted form of transport for the trees' male genes that having to rely on their pollen blowing about willy-nilly in the wind. As cycad species spread across the globe, so did subtle changes in the aromas they produced, each species evolving its own special scent. As clusters of similarly inclined beetles found themselves attracted to the same types of trees, their gene pools become localized or isolated in the process, with each separate community evolving into its own distinct species as successful characteristics became predominant. How humans have become so familiar with such a wide variety of species is largely thanks to the effort of European beetle hunters. One racing collection began by Sir Peter the Great runs to more than 6 million individual specimens, each one separately housed, mounted, listed, and labeled. The fascination for beetles in Darwin's day among British Victorian naturalists was just as pronounced. On one occasion, Darwin was out hunting for beetles and was holding a specimen in each hand when he saw another, even rarer example. His eminently practical response was to put one of the beetles he was holding into his mouth for safekeeping so he could retrieve the third. In the process, he made yet another scientific discovery. In confined species, some beetles eject a noxious poison. How to pick out a single representative from the 300,000 or so known species living today present another interesting challenge. One candidate, venerated since the beginning of recorded human history, is the scarab or dung beetle, a creature that feasts off the excrement of larger animals. The scarab's preference is for the dung of herbivores such as elephants, camels, cows, and sheep. So enthusiastic are these creatures for their share of the cake that in some parts of the world thousands of beetles converged within moments of fresh helping landing on the ground. Some Australian dung beetles have even developed a knack of clinging to the hairs around the wallaby's anus, just to make sure they are first in line when it comes to fresh deliveries. Scarab beetles knit down into spherical balls that they roll across the ground to a suitable place for burial, providing a rich store of food. Female scarabs lay their eggs inside the ball, giving their young larvae a source of protection as well as nutrition. Ever since large terrestrial herbivores began to make their mark, starting in the age of dinosaurs, the ecological contribution of these assiduous recyclers has been immense. Even today, it is estimated that the U.S. cattle industry alone saves $380 million a year thanks to the breeding of livestock species by scarabs and other insects. The ancient Egyptians venerated one species, Scarabaeus caesar, as a living god on earth because of its down-roaring antics recorded in many scarab-shaped amulets. Funeral brooches, pictures of scarabs were also painted or etched onto the walls of ancient Egyptian tombs. Mm. Dragonfly, order Purotodonata, species Meganeuropsis palmiana, rank 50, a fearsome fixed-winged insect that once dominated life on land from the skies. Aggression is an instinct most often found in species at the apex of the pyramid of life, a natural arrangement of creatures that occurs in all ecosystems. Light from the sun is absorbed by plants and turned into sugars. Herbivores, creatures who feed on plants, stand to gain only about 10% of the sun's trapped energy, since the rest is used by the plants for their own growth and reproduction. Further up the pyramid, the number of species and the size of populations get smaller and competition for survival increases. Carnivores, creatures that feed on other animals, stand to gain only about 10% of the ener- energy pyramid in herbivores. Therefore, in their bid to survive, these species have to be the most aggressive of all. Many of the most spectacular examples of the survival of the strongest over the weakest, one of Darwin's recurrent themes, come from species at the top of this pyramid. Over the course of evolutionary history, the fortunes of the super species at the top have risen and fallen like stocks and shares today, sometimes descending into a niche or occasionally going bust and sinking into extinction. Among the land's earliest animal kingpins were the dragonflies. The aggression and success of ancient dragonflies arose partly from the fact that these insects were among the first to take the skies. High levels of oxygen in the uh, Carboniferous periods atmosphere and the increasing height of plants as they morphed into the Earth's forest trees are likely to have assisted insect first flight. It is not too difficult to imagine how it may have happened, even if no fossil evidence has yet been found of insect uh, proto-wings uh, flaps originally designed to regulate the body temperature could have gradually adapted into wings, and some derived daredevils. Some daredevils probably experimented with gliding from tall plants to the ground rather than crawling all the way back down. Over time, muscles developed to assist the gliding process itself, made easier by the dense atmosphere, which contained greater quantities of atmospheric oxygen derived from the uh, forestation of vast tracts of formerly barren land. Higher oxygen levels also help to explain why the ancestors of today's dragonflies were able to grow quick so large, powering them with the extra energy needed for growing and flight. Um, um, Griffin flies, an extinct order related to today's dragonflies, grew as large as eagles, swooping down from the skies with a wingspan, wingspan swooping. Uh, Swooping down from the skies with a wingspan of more than half a meter, these creatures preyed on unsuspecting terrestrial animals. Compound eyes, perhaps descended from those of the trilobites, reached their uh, zenith in flight like this. Typically, the lenses features more than 30,000 individual uh, facets, providing a near 360-degree view of the world. Such used flies could either indulge in a small, juicy, four-legged vertebrate or alternatively devour less powerful insects. A major impact of their of intense predation. Uh, um, Intense predation was the development of the folding wing in other insects, a characteristic of the group Poly, Polyneoptera. Mhm. The design uh, sought to have evolved as a defense against the dragonflies, allowed vulnerable insects to creep under logs or into uh, creep under logs or into crevices and cracks in rocks to escape becoming a fixed-wing predator's prey. It is therefore thanks to dragonflies and their ilk uh, that highly successful escapologist, escapologist is, um, uh, escapologist in instincts and skills of houseflies, beetles, wasps, bees, ants, and other flying folding winged insects ultimately evolved, a process that began from the later Ca- Carboniferous period onwards. For as long as 50 million years, the skies were ruled by giant dragonflies such as Meganeuropus palmiana and griffinflies Meganeuramoni, the largest insects ever known, but being became at price, making them more susceptible to sudden environmental change. Declining oxygen levels probably contributed to the demise of these enormous creatures. Insects do not have lungs. Instead, they rely on oxygen diffusing through their bodies via small tubes called trachea. Trachea. Structure. Large, large flyers, large flyers therefore depend on high large flyers therefore depend on high concentrations of oxygen, so the life-giving so the life-giving gas can mm, properly permeate throughout their body. When oxygen levels fall, the maximum possible size for flying insects fall too. Today, smaller dragonflies thrive. Nonetheless, they express their powerful inherited instinct for survival in at least two remarkable uh, ways. First, a dragonfly's genius at acrobatic flight usually means it can use its near 360-degree vision to catch its uh, hapless, hapless hapless. Hapless victim while still on the wing. Spine-like studs jet out from its legs, forming a from cage-like grip from which there is no hope of escape. Some flies take their meals back to their roots, as they prefer to consume their catch fresh while still aloft. A second highly aggressive survival strategy is sexual. Charles Darwin wrote about sexual selection as a force of variation between genders of the same species in his On the Origin of Species. These sexual antics of dragonflies offer an extreme example of sexual competition between males. Was example see having identified a compatible mate, color, and flight patterns acted species hallmarks, a male dragonfly will grasp a female by the neck in mid-flight and hold her there, therefore, as long as it takes to transfer his sperm successfully. Uh, uh, her mate, a male dragonfly will grasp a female by the neck in mid-flight and hold her, therefore, uh, as long as it takes to transfer his sperm successfully. The two of them will form what is known as a copulating whale, the male not releasing his grip until the female yields, even if it takes several hours. In a in a unique evolutionary adaptation, the male's genitals are designed to scoop out any sperm already inside the female that may have been placed there during a previous liaison. designed to scoop out. The scoop out any sperm already inside the female that may have been placed there during a previous liaison. The re, rea, rea, reason, reason, uh, reason. The dominant male will then attempt to hold the female hostage until the hostage. Uh, hold the female hostage until she has laid her eggs. A final bit to ensure other males of the same species do not repeat the trick he performed. In such a manner, uh, do genes uh, from the strongest, most dominant individuals get uh, passed on by inheritance to future generations. Such tactics are nature's surest way to cultivate a predator, predatory master race.